Hello everyone and welcome to the hands-on demo on Amazon Neptune. So in this demo, we will create a Neptune database cluster. We will configure EC2 for access to Neptune database cluster. We will load sample social network data. We will execute graph queries for friend recommendations. We will run some interactive queries and finally we will clean up all the resources. So step 1 is to launch Amazon Neptune database cluster. So I have logged into AWS console home and I will search for Neptune. Click on Neptune. So this will be a provisioned database type and the latest version, and I will call this database cluster as social network graph. So click on launch Amazon Neptune, provisioned, development and testing, and database cluster will be social network graph, and this is the engine version, the latest version. And if you just scroll down, default Neptune IO optimized and bustable classes, this is free tier eligible, and multi-easy deployment no. So I'll just choose the default VPC and default subnet group. VPC security groups, choose existing and just select the default one. Additional settings, so database port default is 8182 and any tags. So I don't need notebook, I'll just unselect that. Turn off IAM authentication, turn off copy tags to snapshot, and default retention period, maintenance window no preference. You can turn off auto minor version upgrade and turn off deletion protection. Click on create database. So these are all the options. So default storage options, configuration, and it's a single easy deployment. We have network and security, so default options, and the port, authentication off, turn off copy tags to snapshot off, retention period no preference, turn off deletion protection. Next, I will create an EC2. This EC2 will be used to connect to the Neptune database. So I'll search for EC2. Open that in a new tab. So I'll call this EC2 client as Neptune client. I'll just choose the default Amazon Linux AMI, the latest version. Instance type will be T3 micro. I will proceed without a key pair because I'll use session manager SSM connection. Default VPC, auto assign public IP enable, and existing security group default. So our Neptune database as well as EC2 will be in the default security group. And default storage options, and I'll make sure I select the SSM instance role. This will be used to connect to our EC2 machine. So click on launch instance. I'll paste the name. Key pair, I'll just select proceed. So T3 micro, and so name Amazon Linux latest version. Instance type T3 micro. Proceed without key pair. So default VPC and select D. So there will be one default VPC security group which I'll choose. So auto assign is enabled. And storage, there is no change. And make sure you go to advanced details and select the SSM instance role. And that's all. And click on launch instance. So this will get launched and I can go to instances, and I'll just wait for this to get initialized, and once this is initialized as well as this is available, then I will resume connecting to our Neptune database using EC2. So this may take around 15 minutes, and now the cluster is ready, and both the cluster as well as the writer instance is in available state. So I'll just click here to basically go to the endpoint. So this will load the endpoints. So this will be our endpoint that we will use to connect. And our EC2 instance is also ready. So I'll just select the EC2 instance and click on connect. Make sure you are on the session manager. Click on connect. So this will open the session manager window. And I'll just go walk you through the steps. So first we will do a sudo -i to become a super user. Then we'll just do a yum update to update the package manager and install the Python 3 pip. Then we'll use this Gremlin Python library to connect to our Neptune database. And we'll install the request library as well. Next, I will set up the endpoint. So I'll take the endpoint value from here, this particular value, and I will set a variable. So first we'll test the Neptune connectivity. So we'll just use the Python API. So we'll create a file test neptune.py and we'll just use the client, the Python library to connect, and we'll make sure that we are able to connect first. Once we are able to connect, then so this is the important part. We'll test the connectivity. We'll load the data. So this data load script will again use the client API from the Python driver, the Gremlin Python driver, and it will create this data. So first it will just clear any existing data if it's there. Next it will create these 7 users and they have name, UID. So these are the UIDs: name, age, city. So this is an array of tuples, and we are just creating this particular data, and we have this like what is the name. So it starts with like person. So we have something called as vertex and edges in vertices or vertex in a graph database. So vertex is basically node and edges is the relationship. So if I say A is friends with B, so A and B are the nodes or the vertices, and friends, this is the relationship. So that is called as edges. So here we are creating this particular starting point, like this person has this particular name, this is the age and the city where that person lives. Then we are just continue to build upon and we will create some interest. So these are some interest. So this is separate. Then we'll link it later. Then we will add the interest, also like interest and the name property. Finally, we'll create some friendship. So now we are creating the relationship. So Alice user is friends with Bob, and Alice is friends with Charlie, and so on. Then we just run through it. So this is the similar pattern. So we'll declare an array of tuples and then we run a for loop, and then we create these relationships based on this and the last value. So add friends. So this will create a relationship, and this, because friends can be a bidirectional relationship, so that's why we have a bidirectional edge as well. Then we will connect the users to interest. So user Alice like hiking, so interest hiking, this is the ID and actual label is here, right? Hiking. And this is how we create this vertices and edge graph. So this will create the users to interest relationship, and then we'll run a for loop and we'll create all this, and this will finally we'll just print out how the graph looks like. So this is the important part. So let me just go to the session manager. So I'll just zoom in first and become super user. Then I'll just install the necessary libraries. Next, I have to set the endpoint. So I'll copy the endpoint. I will take the endpoint by coming to the social networking network graph and just scroll down and take the first endpoint name and come here, and so I'm setting the variable. So first we'll create a test connection. So this will create the file, and once the file is created, I can do Python 3, the file name, and provide the endpoint. So you can see successfully connected current vertex, which are the nodes. So currently it's empty, so it's saying count 0. There is no data in the database. Next, we'll create the data load script, which I explained. Press enter, and that will create this particular file, load data v1. Now I can go ahead and run this Python script. So it is first, it will clear any data is there. Then I'll just scroll, and this will make it clear what the program is doing. So first it will create the users as I talked about. Alice, Bob, Charlie, Dinah, Eve, Frank, and Grace. So these are our 7 users, and they have these IDs. Next, we have these interests. So these are hiking, photography, cooking, music, reading, and those are the IDs for the interest. So it will just say it has created till now 12 vertices. Then we have creating friendships. So it has connected user Alice with Bob, user Bob with user Alice with Charlie, Charlie with user Alice, and so on. So it has created some friendships between them. Next, it is connecting users to interest. Alice likes hiking. So that's why I said the relationship can be one way or it can be bidirectional. So in this case, Alice likes hiking. It cannot be hiking likes Alice. So this is one way. So it is connecting users to interest. So we have created some interest and users. Then we are doing a final verification. There are 12 vertices in our whole graph, right? So we have 12 nodes, and these are total edges are 24. So there are 24 arrows which are going among those 12 nodes. So sample connections, for example, Alice friends are Bob and Charlie, which we have seen from here. Alice, Bob, Alice going to user Charlie. So these are just, I have outputted 2 values, and Alice interest are photography and hiking. So if we just scroll up, so Alice likes hiking and photography. So it has given the just for a single user, right? So this is how a graph looks like, and this is used heavily in social networks, for example, Facebook, LinkedIn, all, and it can do recommendations and all as well. So I'll just go to the next part. So we have done the we have done the data loading. Now we'll create a graph queries. So I'll copy the whole script, and now we are doing the querying to the graph. So this will say Alice a direct friend. So it will continue. So this will just print out, and friend recommendations for Alice. So based on the degree, and if I just go down, the third part, people with similar interests to Alice, and connection path Alice to Grace. So you can also count how many nodes are there. So it is direct 1-to-1, or how many nodes are there in between. And last part, most connected people in the network. So it will print out who are the most connected and what are the most popular interest, and people who are in Alice city, Seattle. So it will we have Alice living in this particular city, right? And then it will go to that, and we'll see who all nodes connect to that particular city, which are part of the node. And Alice extended network, which are 2 degree of from like A, B, C. So A to C is 2 degree, right? So this is the complete script, and if I show you the output, it will become more clear. So I copy the program and paste it, press enter, and now I'll show you the output. So we are querying the complete graph and getting some analytics based on that. So if I just go up, you see Alice direct friends, which we have already seen from our sample, but now we are doing friends recommendation for Alice. Friends of friends who are not already friends. So Dinah and Eve, mutual connection via your friends. People with similar interest to Alice. So we have Dinah, Grace, Charlie. They have one common interest. So connection path Alice to Grace. So it will calculate. First it goes to Charlie, then Eve and Grace. So degrees of separation is 3. So most connected people in the network. So we have Bob, 2 connections. So all of them have 2, 2, 2. So these are the most connected people in the network. Most popular interests. So hiking, there are 3% who likes hiking. Then cooking 2%, photography 2%, music 2%, and reading 1%. people in Alice City, Seattle. So there are Bob, Frank, and Dinah. Alice extended network. So there are 2 degrees. So there are 5 people who are 2 degrees, and those are Alice, Bob, Charlie, Dinah, Eve. And this is the complete analysis of the graph querying. Lastly, I'll just do a interactive session. So I'll create an interactive query, interactive.py file. And now we can run interactive queries as well. So I'll just say Python 3 interactive and the endpoint name. So this will open a Gremlin query language or Gremlin interactive session. So here we are just doing how many vertex count are there. So there are 12 total nodes as we have seen already. And if you want to see like this vertex has label person and values name. So we are just getting the name of all person. So these are 7 persons and their name. So this is how we can traverse the graph. This will do Alice, fence, what are their names? So out edges. So Alice out, name of the arrow which is fence, the relationship, and values, what is the value? It will just print out whatever is the column name. Bob and Charlie. Next is the Alice out likes, what is the what Alice likes. So basically these are the interest. And lastly, again has label person, has city Seattle, and who lives in Seattle. So Bob, Frank, Alice, and Dinah. So this is how we can query using this particular graph query language. Okay, and I think this is all. So I'll just zoom out. So we have run the graph queries. Finally, we'll clean up all the resources. So first I will delete the Neptune database instance. So I come here and I can select the writer instance, actions, state, and delete instance. Don't create final snapshot, and copy confirm value and delete. So if you delete this, it will automatically delete the whole cluster because there is only one writer instance. So this is going into deleting state. Very soon this will also become deleting, and you should come back after 5-10 minutes and make sure this is completely gone. If any part is still there, you can select the radio next to it and go to actions and state and make sure everything, you just click delete and there's nothing left. So this whole thing will go away. Next is to just delete the instance. So select the EC2, actions, instance state, and terminate, delete instance, and click on terminate, delete. So this is starting the successfully initiated termination. If I just refresh, you can see shutting down already. So this anyway should go away, but you can come back and check. So you can just close this tab as we don't need anymore. And these queries will be part of resources. So if I just come here, so you can see now this also has gone into deleting state, and this will go away because we just have only one writer instance. So this will also get deleted maybe around 5 to 10 minutes. And right, and that's all. Thanks for watching.